So I'm going to make a video to try and help out with the cross product of two vectors. Yesterday we studied about the dot product of two vectors, and when we do the dot product of two vectors you get a scalar for a result. That means a vector dot a vector just gives you a number, not an ordered pair or an ordered triple or anything like that. This is a lot different than what we're going to be looking at today, because today we're going to look at what happens when you do the cross product of two vectors. So the cross product of two vectors produces a vector for a result, and the vector is always perpendicular to the original two vectors. So in a situation where you're doing u vector cross v vector, you get a third vector that's perpendicular to both u and v. And so you can only do it with three-dimensional vectors because you need to have a 3D result. The formula for cross product is u cross v equals the magnitude of u times the magnitude of v times the sine of the angle in between them, and then we have this little n caret here, which is a unit vector, normal or perpendicular to u and v. So I've got a colored example down here below. I'm going to do r cross b. So I want you to take a look at this diagram right here. I've got two vectors, vector b in blue, 8 units long, vector r in red, 5 units long, and the angle in between them is 30 degrees. Well, the main thing to note is that when you do the cross product, you're going to get a third vector that is perpendicular to those two. In order to be perpendicular to both of them, it has to either be coming straight out of the page like this, or it would be going into the page or off of the page underneath the desk. So this vector right here, this marker represents a vector perpendicular to both r and b. And we're going to determine how long it is and what direction it takes depending upon whether we do r cross b or b cross r. So let's give it a try. Down below here I'm suggesting that we do r cross b. And the formula simply says take the magnitude of r times the magnitude of b times the sine of theta times n caret. And this is the part that we'll talk about here in a moment. So let's first of all put our numbers in there. Looking at our values, the magnitude of r is 5. The magnitude of b is 8. The sine of 30 degrees we'll get to in a moment. But what is n caret? Well, n caret is going to be the unit vector that is either coming straight out of the page, coming like this, or going back into the page, and it's determined by the right-hand rule. And it's much like opening or closing a faucet, or taking the lid off of a jar of pickles, or tightening a nut. You follow the same principle of righty-tighty or lefty-loosey. So in this case, we're doing r cross b. Starting with vector r, we're going in this direction. Well, that's a counterclockwise direction, and when you turn things counterclockwise, you're loosening them. They're coming up. Imagine there's a jar here, and if you turn the jar this way in that direction, the lid of the jar in that direction, the cover is going to come up. And so the cross product is going to produce a vector that is coming out of the page. So when I do the math with this one, this is as easy as it is. 5 times 8 times the sine of 30, 5 times 8, the sine of 30 degrees, 1/2. And so we say we've got 40 times 1/2 is 20. And then we just need to simply say the direction. Because we're doing r cross b, starting at r and going in this direction towards b, that means the result, lefty-loosey, turning counterclockwise, you're coming out of the page. So the magnitude is 20 and the direction is perpendicular to these two out of the page. Up here we're doing a similar idea, but this time we're going backwards. So that means I've got to erase this arrow right here, and b cross r means you start at b and you go towards r in this direction. Well, turning in that direction is like going this way, and that's tightening the jar of the lid, the lid of the jar. The lid is going down into the page. You're tightening it, the lid's going down. So the direction of the direction of the unit normal will be down into the page. So considering that, magnitude of B, 8, magnitude of R, 5, sine of 30 degrees, but this time the direction is going to be into the page. 8 times 5 is 40, times the sine of 30 is 20, and then we're going to say into the page. So that R cross B and B cross R produce the same magnitude, but opposite directions. They have to be in opposite directions. If the vectors are algebraic, as I've just shown you them here, there's a shortcut method for calculating it. I'm going to give you the note to show you as much, but for now, let's just see if I can do a simple example here. So 3, 4, 7 is vector R, and we want to do R cross B. So if we're going to do R cross B, we're going to list the vectors in a little matrix, and we're going to take the down products minus the up products. So this is how it looks. We've got vector 3, 4, 7. We're going to list it 3, 4, 7 on the top, and we're going to do it twice. And then we're going to take and do the same thing with the B vector, and we're going to list those numbers twice right underneath it. 2, -1, 5, 2, -1, 5. And what we're going to do is find an ordered triple by doing 3 crosses. So first of all, we forget about those, and we make these 3 crosses right here, and this is the down, and this is the up. Down, up, down, up. So in that case, we're going to create an ordered triple like this, a vector that's going to be perpendicular to both of these. So let's begin by looking at this first cross, the down, 4 times 5, 20, minus the up. -1 times 7 is -7. We want to minus a -7. Down product minus up. Down product, 7 times 2, 14. Up product, minus 15. 7 times 2 minus 5 times 3. And then here down, 3 times -1, -3, minus up, minus a negative, minus 8, not -8, like that. So as we multiply these, or as we do the math on these now, 20 subtract a -7, you get 27, comma, 14 subtract 15, -1, -3 subtract 8, -11. This vector represents here R cross B. And this is a vector of a certain length, but it's definitely perpendicular to these two. So to finish off, I want to show you how I know they're perpendicular. And I'm going to take you back to the dot product and remind you that when you do the dot product of two vectors, A dot B will equal 0 if A is perpendicular to B. Well, we know that this green vector down here is perpendicular to both of those. So that if I take 27, comma, -1, comma, -11, this green vector down here, and do a dot product with either one of these, we should get 0 for an answer because it is perpendicular. Well, let's try the dot product and see what we get. Dot product would be 27 times 3 plus -1 times 4 plus -11 times 7. And that gives you 81 minus 4 minus 77, 0. What does that imply? That implies that this green vector right here is perpendicular to the red one. Likewise, we could do the dot product between the green and the blue and find that it would be also perpendicular. We won't do that right now. So That's the idea of the cross product. It's producing a vector perpendicular to the other two vectors that you're doing the cross product of. That's the end of our video for today. Have a good one.